Welcome to Deep Inside Biosciences. In part 6 of graph interpretation, let's uncover what every curve and pattern is trying to tell us. Before moving ahead, let's revisit our graph family roadmap. We have completed the compare family and the line chart from the change family. Now in part 6, we will continue with the area chart. Now let's understand what an area chart is. First, data points are joined by a line just like in a line chart. Then the space between the line and the baseline is filled with color. Here, biomass increases from 8 to 66 grams per square meter over 6 ordered weeks. The line shows the trend or direction of change, while the filled region emphasizes the magnitude or size of the values. So, an area chart highlights both change and quantity across an ordered axis. Now, let's look at the different names used for area charts. Area chart is the standard and most commonly used name. It may also be called an area graph or a fill line chart because it is simply a line with color filled below it. The area chart family includes simple, basic, multiple, overlapping, stacked, 100% stacked area charts and stream graphs. Simple and basic area charts are often named for the same basic forms. Remember, all these graphs belong to the area chart family, but each one serves a different purpose. Now let's understand the 6 types of area charts. All use the same timeline but display biomass differently. A simple area chart shows one data series. A multiple area chart shows 2 or more series, but one filled area may hide another. An overlapping area chart uses transparent colors, allowing the series to remain visible. A stacked area chart places components on top of one another to show their contribution to the total. A 100% stacked area chart shows percentage contribution but hides the actual total. Finally, a stream graph flows around the central baseline. It looks attractive but is harder to read. Therefore, choose the type based on whether you need one trend, group comparison, totals, or proportions. Now let's understand the structure of an area chart using these 8 parts. The title tells us that the graph shows biomass over 6 weeks. The x-axis represents time in weeks, while the y-axis represents biomass measured in grams per square meter. The baseline usually represents 0. The data points show the measured values such as 8 in week 1 and 66 in week 6. The boundary line connects all these points and the filled area extends from this line down to the baseline. Finally, the legend identifies the displayed data as biomass. Together, these parts help us read the area chart correctly. Now let's learn how to read an area chart in 7 simple steps. First, read the title, biomass over 6 weeks. Second, check the x-axis, which shows weeks 1 to 6. Third, check the y-axis and its units, biomass in gram per square meter. Fourth, inspect the scale. It runs from 0 to 70 with intervals of 10. Fifth, read the exact values from the boundary line, 8, 14, 25, 40, 54 and 66. 6. Observe the filled area to understand the overall magnitude. Finally, compare consecutive weeks to see how biomass changes over time. Remember, use the boundary line for exact values and the filled area for overall magnitude. Now let's compare the week to week changes. To calculate each change, subtract the earlier value from the later value. From week 1 to week 2, the increase is 14 minus 8, which equals 6. The next increase are 25 minus 14 equals 11. 40 minus 25 equals 15. 54 minus 40 equals 14. And 66 minus 54 equals 12 grams per square meter. The largest increase occurs from week 3 to week 4, where biomass rises by 15 grams per square meter. So biomass increases every week, but the amount of increase is not the same. Now let's interpret this graph as a simple plant growth story. In week 1, small plants have a biomass of 8 grams per square meter. As more leaves and stems develop, biomass rises to 14, 25 and then 40 by week 4. Rapid growth continues, reaching 54 in week 5 and the highlighted measured value 66 in week 6. There is no decrease between the measured week, and the fastest gain occurs from week 3 to week 4 with an increase of 15. However, the dots are the actual measurements, while the line is it's only a visual connection. It does not prove what happened at every moment between weeks. Overall growth becomes faster at first and then slightly slower after week 4. Now let's explore how area charts are useful in life sciences. They are useful when a quantity changes or accumulated along an ordered axis, such as time, age, dose, or developmental stages. They can show cumulative biomass, seasonal abundance, resource consumption, population dynamics, energy content, species richness, ecosystem composition, drug concentration, and gene expression. Stacked areas can also show how cell population, nutrients, or metabolites contribute to a total. In exams such as CSIR NET, DBT, JRF, GATE, and university exams, you may be asked to identify a trend, compare time points, calculate absolute or percentage change, or interpret stacked components. So identify the ordered axis and then determine exactly what the field area represents. Now let's understand 5 common mistakes while reading an area chart. First, do not read exact values from the field region. Read them from the boundary line. Second, never ignore the units. Instead of saying V4 equals 40, say 40 grams per square meter. Third, opaque overlapping areas may hide one group, so use transparency to keep both visible. Fourth, do not assume the color represents another variable. Here, it simply fills the biomass area. Fifth, do not assume continuous measurement. Only the dots are actual weekly measurements, while the line is merely a visual connection. So use the boundary line for values, check the units, and remember that only the dots were measured. Now let's continue with 4 more common mistakes. The 6th mistake is ignoring the scale. Always check the starting point and whether the intervals are equal, because a distorted scale can make the trend looking misleading. The 7th mistake is misreading an upper stack. At week 6, the total height is 66, but species B is only the thickness of its band. 66 minus 36 equals 30 grams per square meter. The 8th mistake is treating the colored area as biological total. Usually, the filled one helps us see the trend and magnitude. We calculate its area only when specifically asked. The 9th mistake is claiming statistical significance from appearance alone. Error bars, sample size, a statistical test, and p-value are needed. Remember, a visually large difference is not automatically statistically significant. Now let's understand when to use an area chart. Choose it when the x-axis has a meaningful order and values change across time, dose, age, or distance. It is useful for emphasizing both the trend and magnitude, showing accumulation, displaying one main data series, or showing components of a changing total. In this example, week 1 to 6 from an ordered sequence, biomass shows an increasing trend and the filled area highlights its magnitudes. Therefore, this is a good choice because the sequence, overall pattern, and size of the values are all important. Now let's understand when not to use an area chart. First, avoid it for unordered categories such as tiger, frog, fish, and butterfly because they have no meaningful sequence. Use a bar chart instead. Second, when exact values are the priority, choose a table, line chart, or dot plot. Third, too many overlapping areas make groups difficult to identify. Use separate panels or a line chart. Fourth, negative values can make the field region and baseline confusing. A line or bar chart is clearer. Fifth, stacked areas are poor for precise component comparison because upper components lack a common zero baseline. Use separate line charts. Finally, if actual totals are important, avoid a 100% stacked area chart and use a regular stacked area chart. Always choose the graph that communicates the data more clearly, not simply the one that looks attractive. Now let's practice some exam-oriented questions. Question 1. What type of graph is shown? It is a simple area chart. Question 2. What does the x-axis represent? The answer is it represents time in weeks from week 1 to week 6. Question 3. What does the y-axis represent? For that, the answer is it shows biomass measured in grams per square meter. Coming to question 4. What is the biomass at week 4? It is 40 grams per square meter. Question 5. When is biomass highest? It is highest in week 6 at 66. Question 6. When is it lowest? It is lowest in week 1 at 8 grams per square meter. Begin by identifying the chart type, axis, units, highest values and lowest values. Now let's explore the trend and calculation questions on the next slide. Now let's explore the trend and calculation questions. Question 7. What is the overall trend? Biomass increases throughout all 6 weeks. Question 8. What is the total increase? For that, subtract the first value from the last value. 66 minus 8 equals 58 grams per square meter. Question 9. Where is the greatest consecutive increase? It occurs from week 3 to week 4. 40 minus 25 equals 15 grams per square meter. Question 10. Is the increase equal every week? The answer is no. The weekly increases are 6, 11, 15, 14 and 12. Therefore, the graph rises every week, but the largest gain occurs from the week 3 to week 4. Now let's conclude area chart with the key takeaways. An area chart is a line chart filled with color down to the baseline. Read exact values and trends from the boundary line and use the filled area to understand magnitudes. Before interpreting, always check the variable, scale, unit and baseline. In a stacked area chart, the top boundary shows the total while each band's thickness shows that's component value. For example, at week 6, species A is 36 and species B is 30, giving a total of 66. Area charts are useful for ordered data, trends, accumulation and magnitude, but not for unrelated categories. Too many overlaps or precise component comparison. Here, biomass rises from 8 to 66 with the largest increase of 15 from week 3 to week 4. Never claim statistical significance without error bars, sample size, a statistical test and p-value. In short, area charts reveal how a quantity changes and how large it becomes across an ordered axis. With this, we have completed area charts. We have completed both the line chart and area chart in the change family. In part 7, we will move to the next chart type, the stack chart, and learn how it displays components of a changing total. Thank you for learning with Deep Inside Biosciences. Let's end this video with a beautiful thought. Hold on to instruction. Do not let it go. Guard it well, for it is your life. This means value good guidance, remember it and follow it carefully, because the lessons you learn can protect you and guide your entire life. This video is also available in Hindi and Telugu. Please like, share and subscribe to Deep Inside Biosciences for more easy learning. Until we meet in the next video, stay focused, stay consistent, because success is in your DNA. Thank you.